Everyone, today we are going to talk about standard deviation and we're also going to talk about two-sample t-test. So when we think of a set of data points, we always assume that our data is symmetrically distributed. And we represent it by a bell curve, and we say that this is a normal distribution of our data points. And we always assume that our data is not skewed to one extreme. So we show the normal distribution of our data points with a bell curve like so. And we would say that right here we have our mean, or the average of our points, represented by the x bar. When we do take a look at this normal distribution, this bell curve right there, we say that there is always a tendency for the data points to cluster around the mean. But of course, there are some data points that are going to be above the mean, or you're going to have some data points that are going to be below the mean. So for example, if this is a bell curve for student test scores, we are going to notice that most students are going to score near the average. But you are going to have some students that score way above average. So for example, they would get like an A+ on their test, and then you are going to have also some students that are going to be scoring way below average. But again, most students are going to be closer to the average. And again, that's a normal distribution bell curve. When we go ahead and we calculate something known as the standard deviation, what is the standard deviation? Standard deviation is basically a measure of how much variation are your set values, or your points, in relation to its mean. So you want to figure out whether the data points that you have, are they all kind of clustered towards the mean of those data points, or are your data points far away from the mean? Again, the mean is the average of your data points, and you usually calculate the mean by adding all of your data points and dividing by the number of data points you have. So if you get, and I'm going to show you how you can calculate standard deviation. So if you get, let's say, a low number for your standard deviation, that would actually mean that your values are close to the mean. Most of your values that you have within that set, they are all clustered towards the mean. If your standard deviation, when you go ahead and calculate it, you get a pretty high number, a high standard deviation would tell you that your values, your data points, they're actually more spread out over a wide range, and it would tell you that your values are actually further away from the mean. So not all of your values are clustered towards the means. Towards the mean, you actually have more variation, and you have your data points more spread out. Okay, so let's take a look at this table together so that we can calculate the standard deviation for each group. So let's say that we have two groups of men. Normal, meaning that this group of men right here, they've never had a heart attack. So everything has been normal with their heart. This group of men right here, we are going to refer to them as recovered MI, meaning that this group of men, they've just recovered from a heart attack, or basically from a myocardial infarction. So for the normal group, I have 11 men, and also for the recovered myocardial infarction, I also have 11 men. I'm going to go ahead and I'm going to, let's say, collect their heart rate. So these numbers right here, it's representing their heart rate. So I have 11 heart rate data points for this group right here, and same thing, I have 11 heart rate data points for the group of men that just recovered the heart attack. Now, I want to go ahead and I want to calculate the standard deviation for the men that have never had a heart attack, and I also want to calculate the standard deviation for the group of men that have recovered from the heart attack. And as we said, the standard deviation is basically you are trying to figure out how spread are the data points and how much variation do you have within your data points from the mean. So you want to figure out, again, how spread are your data points from the mean. Now, how do we calculate the mean? So the mean for this group right here is 70.9, and we note the mean by a symbol of X with a line on top of it, so we call it X bar. And so how can we calculate the mean? To calculate the mean, first you want to sum up all of your data points. So this symbol right here, it's summation. So you would sum up all of your data points. So I would do 83 plus 61 plus 80, etc. And that should give you 780. Go ahead and try it out and see if you get the same numbers. So add up all of the numbers and it should give you 780. Then what am I going to do with that 780? I would take that number, the 780, and I'm going to divide it by the total number of data points that I have. And so I have 11 data points. So 780 divided by 11 would give you the mean. So to calculate the mean, you add up all of your data points and then you divide by how many data points you have. So in this case, 780 divided by 11 should give you 70.9 as the mean. I want to eventually calculate the standard deviation. I want to figure out whether those data points right here, are they close to the mean or are they spread out? And they are spread out further away from the mean. One more thing to go ahead and calculate before we start setting up our standard deviation equation together is go ahead and square each data point and then add them all up. So I would take every single data point and I would square it. So 83 squared, 61 squared, 80 squared, etc. And I would add all of them up after squaring them. You should get something like 56,264. So let's go ahead and set up our standard deviation together. So the standard deviation, this is the equation for the standard deviation. So let's go ahead and set it up together, and I'm going to calculate the standard deviation for that normal group. You would just follow the same steps and calculate the standard deviation for the myocardial infarction recovery group. So here is my square root. So the first thing, to go ahead and write down is n. N is how many data points do you have? So I have my 11 data points. And then you're going to multiply that by the summation of x squared. So the summation of x squared, which is basically first you're squaring each data point and then you're summing those squared data points, is the 56,000. Okay, and then you're going to subtract. Now, if we look right here, it says subtract your summation of your data points and then square that. So the summation of my data points is 780, and I'm going to square that. Now, make a note that there is a big difference between saying summation of x squared and summation of x and then squaring the whole thing. So those two are not the same. So this one right here, you are basically squaring each data point first and then adding them up. For this one right here, you're taking the total of your summation of your data points and then you're squaring the total. So 780 squared should give you 608,000. Notice how it's not the same as 56,000 because again, you're doing two completely different things. N down here is 11, one more time, and then n minus 1 should give me 10. Okay, so let's go ahead and calculate it together. So you would take 11 multiplied by 56,000, then subtract the 780 squared. So that should give you the following. And then 11 times 10, so that should be the 110. Okay, what I would suggest you to do first is when you go ahead and punch it in your calculator, I would take first 10,504 divided by the 110, and then after I get that answer, I would go ahead and square root it. When you square root it, you should get 9.8. Now we say plus and minus, and why do we say plus and minus for the standard deviation? Because again, standard deviation is we are trying to figure out how dispersed are your data points. So that just means that your data points are dispersed either above or below the mean by 9.8. Now you would do the same thing to calculate the standard deviation for the other group. And notice how for the other group, after you go ahead and you set up your standard deviation equation, you would get 6.8. So what does that tell you? It just tells you that the group of men that have recovered from that heart attack, when you look at the data points, those 11 data points, since the standard deviation is lower compared to the other group, that would just tell you that this group right here, the data points, they are closer to the mean compared to the group of data points from from the normal group on the other side. Since the standard deviation here for the recovered is lower, it's like 6.8 right here compared to the 9.8 right there. Now, by the way, notice how the standard deviation, you are taking the square root of this whole entire equation. If you remove the square root, we don't call it standard deviation, we call it variance. So standard deviation is basically the square root of the variance. Now, we use the standard deviation to go ahead and help us calculate what's known as a two-sample t-test. So let's go ahead and take a look at what is a two-sample t-test and how can we go ahead and calculate it. There is a statistical test known as the two-sample t-test, and we go ahead and we calculate a t-value, and we use that test when we want to compare two means. So we want to compare the means of usually two related groups, and we want to figure out if there is a significant difference between those two means. So we come up with two hypotheses, two educated guesses. The first hypothesis, we refer to it as the null hypothesis. And the null hypothesis, we refer to it by this symbol right here. And the null hypothesis is we are saying that there is no significant difference between the two means. The alternative hypothesis we are saying that there is a significant difference between the two means. So kind of like how we just looked at the the two data points for the men for the heart rate. If you remember, if you recall, the group that had that have never had a heart attack, their mean was 70.9, and the other group of men that recovered from the myocardial infarction, their mean from their data points, it was 70.4. So you have one mean that's 70.9 and one that's 70.4. Now, looking at those two numbers, 70.9 and 70.4, they're not identical. And so what we are trying to figure out is whether there is a significant difference between a mean of a 70.9 and a 70.4. So is there a significant difference? Or is that slight change that, or slight variation that you're seeing from 70.9 and 70.4, is that slight variation normal, or there is a significant difference between those two means? So for us to really figure out whether there is a significant difference between those two means, or again, whether it's just a normal variation and that variation is just due to chance, we go ahead and we calculate the t-test. So back to this table right here of the heart rate of the males that did not have a heart attack and those that recovered from it. If we go ahead and calculate the mean for that first group, it would be 70.9, and then for that second group, their mean of the data points was 70.4. Now, if we want to figure out whether those two means of those two groups are significantly different, or whether there is a bit of variation, but it's not such a significant difference. So as you can see, there is a slight difference. One is 70.9 and one is 70.4. We want to figure out whether that slight difference, is it really that significant, or whether that's just a normal variation, and it's not really it's not really a significant difference, and probably that difference is just due to chance. So for us to figure that out, we go ahead and we calculate what's known as the t-test. And so to calculate basically and to go ahead and perform that t-test, we are going to follow the equation down below. So let's go ahead and calculate it together. So first thing you want to do is take the mean of your first, basically the mean of the first group data points. And so the mean right here was, for that first group, was 70.9. And you want to subtract and get the mean for the other data point. So it was 70.4. Okay, and then you're going to divide, and you're going to put your square root, and they're telling you take the standard deviation of the first group and square it. So the standard deviation of my first group was 9.8, so I would take my 9.8 and I would square it. And then you're going to divide that number by your data points. You had 11 data points, and then you're going to add your standard deviation of your second group. That was 6.8, and one more time, you're squaring that, and one more time, you are dividing by the number of data points. Okay, so what I would suggest you to do first is first go ahead and calculate that top part. So 70.9 minus 70.4, so that's 0.5. And then what I would do is put the square root. First, I would go ahead and calculate 9.8 squared. Take that value, divide it by 11, and so that should give me 8.7. And then I would do the same thing, punch in my calculator, 6.8 squared divided by 11, and go ahead and try it out. It should give you 4.2. Okay, and then the reason why I'm taking it step by step, because sometimes when you punch in everything right away in your calculator and you don't put the correct parentheses, etc., you would get an incorrect answer. So by working it out first and then punching in less numbers in your calculator, usually you avoid mistakes. So 8.7 plus 4.2, that's 12.9. Okay, so what I would do is just kind of one more time, put my 0.5. I would square root the 12.9. So square root of the 12.9 is 3.59. Now I'm ready to go ahead and divide. So 0.5 divided by 3.59. My calculated t-value is 0.139. So 0.139 is basically my calculated t-value. Why do I call it calculated? Because we went ahead and we calculated it together. So we call it your calculated t-value. So your calculated t-value is 0.139. Okay, I have my calculated t-value. Then what? Again, that doesn't really tell me whether my two means are significantly different, or again, whether there is no significant difference between the two. And so we are going to have to calculate something else. Okay, so we went ahead and we calculated the t-value and we got 0.139. Now, for us to figure out if there is a significant difference between those two means or not, there's something else that we have to calculate, and it's known as the degrees of freedom. To calculate the degrees of freedom, all you would do is take the number of your data points and subtract 1. Now, for this example, we had 11 data points for the first group, and we had 11 data points for the second group. So our data points were exactly the same, 11 data points, and so all I would do is 11 minus 1, and for this example, the degrees of freedom is 10. Now, the thing is, you don't always have to have the same number of data points for both groups. Let's say in another scenario, you collected data points from 13 individuals for the first group, and let's say that for the second group, you were only able to collect data points from 11 individuals. And so in this case, your degrees of freedom, since I have two different number of data groups, so let's say that for the first one, I have 13 data points, and let's say that for the second one, I was able to collect data from 11 individuals. So that would give me, 10 for this one, and I would get 12 for that one. So one more time, if your data points, it's not equal, so you have 13 data points for one group and you have 11 data points for another group, which one should I go with, 12 or 10? Just go with whichever is smaller. So in this case, you would still go with the 10 because it is smaller. But for our scenario, we didn't really have to, think about it or compare, because we really had the same number of data points for both groups, 11 data points. And so after you get your degrees of freedom, you go ahead and use this table right here, and you find your degrees of freedom. So you would find your degrees of freedom, which is 10, and that tells you what's your critical t-value. So this t-value from this table right here is 2.23. So my critical t-value is 2.23. Now, that's the critical t-value that I got from the table. The one that I calculated earlier was 0.139. Okay, so remember how we had two hypotheses? The null hypothesis is we don't have any significant difference, um, or you're not going to have any significant difference between the two means. And the alternative is you are going to have significant difference. So the two rules state the following. If your calculated t-value is greater than the critical t-value, then there is a significant difference, and that would mean that you would accept your alternative hypothesis. But if your calculated t-value is less than or equal to the critical t-value, then there is no significant difference, and that would mean that you are going to be accepting your null hypothesis. So let's take a look at our values. So the t-value that we calculated was 0.139. The critical from the table is 2.23. That means that in this scenario, our critical t-value is greater. So your calculated t-value is less than the critical t-value. And so what does that mean? If it's less, that means that there is no significant difference between the two groups. And if there is no significant difference between the two groups, that would mean that I'm going to be accepting, so I'm going to accept basically my null hypothesis. And what does that mean? It means that the difference that you saw between those two different groups, that difference in the mean of like the 70.9 and the 70.4, even though there is a difference between the two means, it's not really a significant difference. And so that's how whenever you want to figure out whether you have significant difference or not between two groups, you would calculate your t-values. And so in this scenario, we are going to accept our null hypothesis because our calculated t-value came out to be less than the critical t-value. And again, it tells us that there was no really significant difference between those two means.